going on, you guys? It's your soft-spoken scientist. In this video, we're going to learn how to identify reaction types. So when you see a chemical equation, you immediately know what kind of reaction it is before doing any math. Let's get started. There's four main reaction types: synthesis, decomposition, single replacement, double replacement. We are not balancing yet. We are only identifying patterns. Let's start with synthesis. So you have two or more reactants that are going to combine to form one product, right? So if you look at the picture, you have one reactant because it's behind the arrow. So this is your reactant side behind this arrow. This is the product side after the arrow. So you have one reactant, and then you have another reactant right here. So you have two reactants, and then you have the product right here, AB. So you had your reactants combined to form one product. So if we look here, we have 2H2 plus O2 forming 2H2O. So if I really look into this, multiple things come together. That's the synthesis. So I have 2H2, I have the H2 right here. I got O2, 2O, because the 2 would get distributed to that O. And all the elements are in the product, and they were separated in the on the left side of the arrow, which is where the reactants would be. And that's synthesis for you. Okay, let's try the next one. We have decomposition. It's the opposite. So it's when one compound breaks apart into simpler substances. Okay, so it's kind of like you have a $20 bill and you broke it into two $10 bills, right? Versus synthesis, it's you have $10 bill, and then you got another $10 bill, and then you form to make $20. You see what I'm saying? So with decomposition, what's going to happen next is that you have, in this example, 2H2O plus 2H2 plus O2. So I see we have something, we're breaking it apart very specifically. We have 2 hydrogens times another 2, which is 4. So we have 4 hydrogens. You have 2 oxygens right there. And you have 2 oxygens right there. So that's how you would do it. Just break apart into simpler substances. Single replacement. It's when you have a substance plus another compound or another substance, and it's going to kind of like cross multiply. So one element kicks out another element. So you have the AC forming. See, they form, and then B is all by itself in the end. So if we look at this example, we have A, Zn, we have B, which is H, and then we have C, which is Cl. And I know A and C are going to form, so it's ZnCl2 plus H2. That came from that. And then the zinc and the chloride came from the charges after we cross-multiplied, right? So I know that Zn, chloride, has a -1 charge. And then I know zinc has a +2 charge. So then the 1 would go here, the 2 would go here. That's like a butterfly cross-multiplication. And you get ZnCl2, right? This is an ionic compound. So this is single replacement. I hope that made sense. Now we are going to see in this problem, zinc replaces hydrogen. And hydrogen's all by itself, womp, 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 right? So now we're going to move on to double replacement. You have AB plus CD is going to form AD plus BC. Or CB, however you want to say that. So the proper way in this example is you have A identified, then B, then C, then D. And then I see A goes to D, the first and last. And then I have the intermediates with what's within combined together. So let's check this out. I would have AgCl, yes, NO3, and then with Na. So NaNO3, because it's C and then B. I just did, B to C to kind of get that formation going. But when you're writing it, this is the best formula to use. NaNO3. So, what I want to make crystal clear here is that you got to identify first and then you're going to balance second. So let's try problem 1. What do you guys think this one is? You got one thing and another thing forming one whole compound. Synthesis. Hopefully you said that. Next, you have 2KClO3 breaking into two smaller things. You got 20 bucks becoming, I don't know, a $10 bill and then another $10 bill. You have two things forming. Decomposition. Next one, you got Fe plus CuSO4 forming FeSO4 plus Cu. So I see I have, let me think. I remember no matter what, when in doubt, I know A, B, C. And then I see A is with C because I have FeSO4. And then I have Cu all by itself. That looks like single replacement to me. And now I have BAC. Well, let's start with what I know. When in doubt, write your letters. A, B, C, D. And I know that I have BA, good, with SO4. Oh, look at that. It's like the rainbow. Look. The first with the last, and then the C would go to B. See, I kind of try to emphasize B as last, I guess, with different colors I tried. BaSO4. And then I have Cl, right? That's with Na. So NaCl, sodium, right? So I have NaCl, and I have 2 from this chloride and 2 for sodium. So I just put the 2 in front. That way the 2 goes for sodium and chloride. And this reminds me of double replacement. What do y'all think? So here's the thing. If you can recognize the pattern, the chemistry becomes predictable. I want to thank you guys so much for watching. Please hit that like and subscribe button. It really will make a difference, seriously. And no, STEM is for everybody, especially you. So keep at it.